Hello friends and welcome at my channel. Today we're going to find the measures of a cone with the biggest volume which is being inscribed into a sphere. So what we do have is the radius of a sphere, which is the black colored line here as you can see, and we are actually looking for the height of a cone, which is this value, and the radius, the small radius of the cone as well. So once again, known is capital R and unknown are H and small r. We have to figure them out. All right, so you see basically 95% of success in this case is the picture which I've done. So this is the degree, 90 degree here, the angle of 90 degree. We got the Pythagorean theorem applicable, and basically we have x squared plus r squared equals to capital R squared. Knowing that, things are getting easier because the formula for the volume of a cone, now still depending on two unknowns or two variables, is a third pi small r squared times h. Well, h is an unknown, small r is unknown as well. And you see h is at the same time the radius r plus x. So I can substitute h by r plus x, and capital R is known, x is unknown, and I can solve for r squared, which would be capital R squared minus x squared in this case. So that means our formula now is changing a little bit. We still have pi instead of r squared small, I'm putting r squared capital minus x squared times h, which is r plus x. Would it help us? Well, it is already very good what we've done because, well, it's not equal actually because I'm substituting. I'm discovering a new formula which is just only dependent on x as a variable and not neither on small r nor on h anymore, which is great. Once again, look at the formula. As an unknown, we have only x, not a capital R squared or whatever. So we're multiplying out here. We're gonna get a third pi still outside r cubed minus x squared r plus xr squared minus x cubed in there. That would be equal to, can we simplify something? No, we can't. All right, so let's keep it this way. We got a third pi r cubed minus a third pi x squared r plus a third pi xr squared minus a third pi x cubed. That's great. Can we produce a derivative of that? Yes, we can. So this is volume dependent on x only. We are looking for its derivative. And once again, x is the only variable. So this is becoming 0. This is a constant value. Here 2 is coming in front. So we got minus 2/3 pi x r, I think. Yeah, then we are having just a third pi r squared. And after that, we are getting just minus pi x squared. You see, this is a quadratic formula. considering x, and we are going to find 0 points of these formulas. So we're putting it equal to 0. We are also dividing it by minus pi. So let's see, we got x squared, then we got plus 2/3 xr. I'm getting rid of pi, and I'm changing the signs as well. And minus 1/3 of r squared equal to 0. You see, minus pi is the factor in front of x squared, so basically we know this is a parabola which is going down, so we do have a saddle point which is at the same time the max. The only thing what we have to consider here is whether this x value would be a positive one, because it's bad if your length is becoming negative, so we wouldn't go for that. And now we just apply one of the formulas that is maybe known to you. So we got our constant is this one. I'm using the so-called PQ formula from Germany. This is minus r divided by 3 plus minus square root out of r squared divided by 9. And now we have minus this one, which is a plus r squared divided by 3. I would like to get the same denominator, so I'm putting 3 here, becoming 9 there. So there you go, we get minus r thirds plus minus, this is 4r squared. If you take a square, it could be 2r divided by 3. So of course, the negative value minus r minus 2r divided by 3 is, well, gone. We just don't need it. As I mentioned previously, we need only positive. We consider only positive values. So the only value which is interesting for us is r thirds. Okay. So we got 2 0 points. Oh, that's great that I mentioned it, but actually this is the wrong function when I mentioned it. I should have mentioned it here, right? I should. And this is a cubic function. Oh, that's not good. So we do compute the second derivative. Let's go. So my argumentation is perfectly fine for a quadratic function, but my function is a cubic one, and it's not applicable here the way I hoped. So let's compute the second derivative. Considering x once again, that would be minus 2/3 pi r. This one is 0, and then we have minus 2 pi x. What is the second derivative at r thirds for x? What about the sign? So we are having, as you can see, definitely a negative value and here a negative one. So this is less than 0. So we got an x. I'm fine with that. So the x value is r thirds. It's great because as you can see, h is r plus x. So this is r plus a third of r. So that means capital H is 4/3 of r. And what about small value of r? Well, you see, small value of r would be a square root out of r squared minus x squared, but since x is a third of r, it is, we're gonna get 1 divided by 9 of r squared. So this is r square root of 8 divided by 3. This is the radius of the cone, and this is its height. Thanks for watching, and see you guys in the next video. Bye bye.